Welcome back to Session 16 of GED Science Mastery. I am glad you are here. Energy is one of the GED's two big focusing themes, so it appears across many questions. The key ideas are beautifully simple and powerful. Energy comes in several forms. It can transform from one form into another, and the total amount is never created and never destroyed, only changed. Get those three ideas, and energy questions become friendly. Here is the big idea in plain words. Energy is simply the ability to make things happen, to do work or cause change. It shows up all around you as motion, heat, light, electricity, sound, and stored energy in things like food and batteries. And here's the crucial point. When you flip a light switch or ride a bike, energy is not made and it is not lost. It only changes form. On a hill, stored energy turns into the energy of motion as you roll down. Energy is always just moving from one form to another. Let's sort energy into two big buckets. Kinetic energy is the energy of motion. Anything moving has it. Potential energy is stored energy. For example, the energy something has because of its height, ready to be released. Beyond those two buckets, energy appears in familiar forms. Chemical energy stored in fuels, food, and batteries. Thermal energy, which is heat from moving particles. And electrical, light, and sound energy. So remember, kinetic is moving, potential is stored, and the forms are just different ways energy shows up. Energy transformations are happening everywhere, all the time. Think about a flashlight. The battery holds chemical energy, which becomes electrical energy flowing through the wire, which the bulb turns into light and a little heat. Or think about your own body. The chemical energy in your food becomes the motion of your muscles. Every device and every living thing is really an energy converter, changing energy from one form into another. When you see an energy question, ask, what form did the energy start as, and what form did it become? Now the headline law, the conservation of energy. It says energy is never created and never destroyed, it only transforms from one form to another. So the total amount of energy always stays the same. But wait. When a moving cart slows down and stops, where did its energy go? It was not destroyed. It usually became heat, produced by friction, the rubbing between surfaces. That heat spread out into the surroundings. So energy that seems to vanish has almost always just turned into heat. Nothing is truly lost. Let's read a real GED-style passage. A part starts at rest at the top of a hill, on a frictionless track. Its energy was estimated at 3 points. A at the top, B in the middle, and C at the bottom. At point A, the potential energy is 800 joules and the kinetic energy is 0. At point B, they are equal, 400 and 400. At point C, the potential energy is 0 and the kinetic energy is 800. Look at the bars. They show the kinetic energy climbing from 0 to 400 to 800 as the cart rolls down. Meanwhile, the potential energy falls the opposite way. Let's answer the key question. What is the total energy at each point? And what does it show? Read. The total is just potential plus kinetic at each point. Choose. At point A, 800 plus 0 is 800 joules. At point B, 400 plus 400 is 800 joules. At point C, 0 plus 800 is 800 joules. Every single total is 800 joules. As the cart rolls down, potential energy converts into kinetic energy, but the total energy stays 800, a perfect picture of conservation of energy. Check. Nowhere does the total change. The energy only shifts from stored to motion. Let's generalize what the cart showed us. On any hill or roller coaster, potential energy and kinetic energy trade back and forth like a seesaw. At the very top, energy is mostly stored. High potential, low kinetic. At the very bottom, it is mostly motion, low potential, high kinetic. But their sum stays about the same the whole way. One important real-world note. On an actual track, not a perfect one, some energy becomes heat through friction, so the moving energy slowly decreases. But even then, the total energy, motion plus heat, is still conserved. Let's lock in the traps. 1. Thinking energy gets used up. No, it is not destroyed. It changes form, often into heat. 2. Thinking potential and kinetic energy are both highest at once. No, as one rises, the other falls, and their sum is constant. 3. Thinking a still object has no energy? No, a raised object has stored potential energy even at rest. 4. Thinking friction destroys energy? No, friction converts motion energy into heat. The recap. Energy comes in forms, it transforms, and the total is always conserved. Wonderful work today. You can now name the forms of energy, trace a transformation, and use conservation of energy to add up a track problem. Your practice for this session is the 10 questions attached to this lesson. Answer them from memory. And for any hill or track problem, remember, the total of potential plus kinetic energy stays constant. To read the full lesson notes and practice more GED science questions, visit the course page at www.bridgetoexam.com. I am proud of your progress. I will see you in session 17, where we explore heat and temperature, thermal energy and how it moves. Keep going. You are doing great.